Greetings and welcome to my new calculus channel. My name is John Gabriel. Today I'm going to be speaking about Euclid's Elements Book 5 and Proposition 3, a very important proposition. In fact, all of Book 5 is very important. That's why I spent so long on the definitions also before this video. So let's see what Proposition 3 has to say. Let's begin. Now, Proposition 3 says that if we have, and I'm going to go straight to it, if we have two magnitudes, this line A that you see in front of you and line C, which are equimultiples of these two small lines respectively, in other words, A is an equimultiple of B and C is an equimultiple of D, then if we take E an equimultiple of A and F an equimultiple of C, then it follows that both E and F will be the same multiple of B and D respectively. Okay, and that's very easy to see because A is made up of B, so it's some multiple multiplied by B. C is some multiple multiplied by D. And of course, if E is a multiple of A, so if E is a multiple of A, which it is in this case, and if F is a multiple of C, F is a multiple of C, then E is a multiple of B. This E here is a multiple of B, and F is a multiple of D, which means that they are both the same multiple of B and D respectively. Okay? So we can form ratios as follows from those. We can say that A in proportion to B, or the ratio A to B, is in proportion to C to D. Okay, in other words, A is to C as B is to D, which implies that F is proportional to E. Okay, so now let's go back and just see what Heath is saying. So Heath claims in a remark that this proposition reads M multiplied by NA is equal to Mn multiplied by A. It says no such thing. Okay. Yes, that's one of the consequences or the facts that follow up on a particular idea, but it's not what the actual proposition is saying. Okay, so it's not saying anything about associativity or anything else that Heath and anyone else in the mainstream academia might think. It's simply stating that K, or some magnitude, called whatever you want to call it, will be the same multiple of B and D. Okay, multiplication is formally defined only much later in Proposition 12, but one has to be exceptionally smart to see this. So again, Heath and David Joyce gets it terribly wrong, because Joyce claims over here that this proposition is not actually a statement about ratios, but it can be interpreted as one. Actually, it is a statement about ratios. It's just that nobody before me actually understood these things very well. So in particular, it's a statement about ratios that are multiples of others. So from this proposition, the foundations of measure nomenclature are being gradually introduced. The answer to the question of how we got numbers is like a puzzle whose pieces are beginning to reveal the big picture. So suppose we choose this line length to be our unit magnitude. It is then easy to talk about multitudes of the unit magnitude using ratios. For example, this could be the unit ratio, or this could be the unit ratio, okay, because both are proportional. This line is to this line as this line is to this line, the unit ratio. Okay, so multiples of the unit are shown here. This multiple of this unit is also known as 2. This is also known as 3, and this is known as 4. Okay, but how do we talk about part of the unit magnitude? So in other words, a fraction. Well, if we want to refer to half of our unit magnitude, we can do this easily via proportional magnitude using the same unit as follows. Okay, so we can use this unit like that, which means that this would represent what we think of as a half in algebra, right? A half in algebra. Because this is to this line segment as this is to that line segment. And this is what is meant when we write that, okay? This is what is meant when we write this ratio is in proportion to this ratio, okay? They're not equal, they're in proportion, but they both give us the idea of a half, because that's what is happening here, okay? This, we use the same unit, and we just represent a half in terms of that unit by changing the consequent of the ratio. So as you can see, and I'll let you have I'll put this in a detail section, so don't worry too much about it, just concentrate on what I'm saying. Rather than trying to further divide up the unit, we simply compose the antecedent and consequent parts as multiples of the unit. So to describe 2 or 3 equal parts, or 2/3, we simply write a ratio like this, okay? 2/3. Moreover, and by the way, these vertical lines are just there to separate they're not really part of the line, and I put it there to make it easier for you to understand, nothing else. So moreover, this line and this line, which are multiples of the same standard unit, tell us how we can give 2/3 a name, right? And the way we can name it is like that. And of course, once we get to algebra, we've given these names, the consequent and the antecedent and the consequent. And so we have in algebra the name 2/3, right? Which is a measure, okay? And the measure is understood in this context, okay? But we've transferred the properties from geometry to algebra. We'll be dealing a lot more with this as we proceed to continue learning about the following propositions. Now, just something very quick. Whenever you read the original elements, the clue to what the proposition says is when Euclid says, I say, εγώ λέω, okay? Εγώ λέω. That's always how you know what he's about to say, okay? So, you can even look at the Greek text, and you'll see that once he mentions all these things, he'll say, I say, and then you know, okay, well, that's what he's talking about. So here he says, EF and GH are equimultiples of B and D respectively. Nothing about associativity, even though it might be a consequence or a lemma or something that follows from the original fact. That's not what Euclid was saying, okay? And of course, Euclid is slowly building up to proposition 12 with all these previous propositions. Well, I think I'm going to leave it at that. My name is John Gabriel. This is New Calculus Channel. Till next time, goodbye.